This is GMAT 41. You are welcome to our ordinary differential equation class. In this video, we don't want to turn our attention to another form of first order differential equation, which is called the exact equation. The exact equation takes the form generally m of x and y. That is a function that depends on x and y. The x plus n, another function, right, that depends on x and y, dy. Make it equal to what? 0. You see that? Whenever a problem is given to you, if it's an exact, before you proceed to solve anything, you must transform it to this format. What does it mean? The n function and the n function, or simply the dx and dy term, should be on one side of the equation, and then you make it equal to what? 0. It's a must. Please take note of that. Now, there is something we call condition for exactness. How would you know if a differential equation is given to you? How would you know that this differential equation is actually an exact equation? Look at the test condition, okay? If you take the partial derivative of the term you call n with respect to y, you should be able to get the partial derivative of n with respect to what? X. So this is the test for what? Exactness. Very important. Memorize it. Now, how do we obtain the solution to an exact equation? Now, the general solution of an exact equation is giving us a function of x, y, which is equal to what? C. That is a function that depends on x and y, which is equal to what? C. Now, if you are solving an exact equation, all you are looking for is this function, alright? This f of x and y. That is the solution of an exact equation. Now, the question now is, how do we obtain that f of x, y? Now, it will interest you that there are two methods. One, the general method, and of course, the second method is the direct integration approach, which GMAT 41 is going to adopt for you. Is that okay? So we'll be focusing more on this step 2, but you can still watch others of our videos in our channel on YouTube, and then you find out, because we are going to see cases of this general method, alright, in it. Now let us quickly look at the various steps taken when you want to apply the general method if you wish to obtain your f of x, y. Now the first thing you need to do is to go to the differential equation given to you and define a term which we're going to call del f over del x. Just write it, del f over del x is equal to the function of n, x, y. That is equal to this term. Then again, define del f over del y and make it equal to n of x, y. So that's the first thing you're going to do. Now, from this first term, del f over del x or del f over del y, is now your choice. Any one of them can be used to get this f of x, y. Besides, you can see that both of them contain that f we're talking about. So any one of them you choose. But we are going to make use of del f over del x. Is that okay? But take note, you can also use del f over what? Del y. Now, in the second method, what do you do? What do you do now? Integrate either equation 1 with respect to x and add a constant which is a function of y. Or, if you decide to use equation 1 to obtain your f of x, y, you integrate equation 2 with respect to y and add a constant which is a function of x. So you see, it's your choice, any one of them. Like I said, we are going to use the first equation, del f over del x, to obtain our f of x, y. That's why I stated here, let us now assume that we used equation 1. Now suppose it is equation 1 you use, it means that you are going to integrate this term, this equation, with respect to what? X. And then add a function which is, that's a constant, which is a function of y. Is that okay? Now, in the third step, what are you now going to do? You are going to differentiate the integral from step 2 above with respect to what? Y. Differentiate the integral you obtained here with respect to what? Y. And then the constant from this step 2 will also be differentiated. And what will it be? Will it be 0 in that case? Like we stated earlier, if you differentiate a constant, you get 0. No, in this case, it won't be 0. Remember that that constant is a function of what? Y. So when you are doing the derivative, it means that this constant you attached here is now going to assume its first derivative. Is that okay? With respect to y. For example, let's assume that from here you added a constant and then you call the constant, let's say h of y. When you come to this step 3 to differentiate the integral from here, this h subscript y, that is h as a function of y, this constant will now assume h prime y. What does this mean? It means dh over dy. That's what it means. That you've differentiated with respect to y. Okay, let us move on. Now in the fourth step, you're going to equate the derivative in 3 above, this derivative. You equate it to del f over del y in equation 2. That is the equation 2 in step 1. What you're going to get from this step 3 in step 4, equate it to this del f over del y, which you have as equation 2 in step 1. Why do you do that? Once you've equated from step 5, the next thing to do is to compare and obtain the value of the differentiated constant with respect to y, which you obtained in what? Step 3. Remember I told you you're going to get a differentiated constant here, right? So during the comparison in step 5, you are going to obtain the value of that differentiated constant. Is that okay? Now once you obtain the value of that differentiated constant, in step 6, the next thing is to integrate that value of the differentiated constant. That integration will now help you to get the value, the actual value of that differentiated constant, which you are now going to substitute in step 2. That is in this integration you did here. Remember, in step 2, you integrated here with respect to what? X. We say we are using this equation 1 to seek for f of x and y. And then you introduce the constant, which is a function of what? X. The value of that constant you don't know. Towards the end here, equation 6 helps you to get the value of that what? Constant. So once you get that value of the constant, you can now come back to step 2 and substitute that value of the constant, and that simply gives you the function, which is the solution of the exact equation that you are looking for. Is that okay? Alright, like I stated, we are going to use step 2, which just carry out a direct integration approach. Now look at this, the differential equation given to you, which is exact. Integrate the n part with respect to x, integrate the n part with respect to y, then equal to c. That's the solution. All you need to do is pick out common terms from these two integrals, alright? And then if there is anything that is a term which is not common to them, which is different, also pick it. That is why I said plus the difference. Is that okay? And that becomes your solution. Very funny, right? As a matter of fact, it's a convenient method to quickly solve and obtain the solution of an exact equation. And like I stated, from GMAT 41, we shall be using this method too more often. We have a very first question on exact equation here on the board. We are to solve the exact equation. So 3x squared plus 6xy dx equal to minus 3x squared plus 3y squared dy. So we are to solve it. Before I proceed to solve this question, I want to state something clearly, right? Because the concept of exact equation is a funny one. All the forms of differential equation that we have discussed so far can be an exact equation. And that is why when a problem is given to you, it's either you are asked to check that it is exact first and then solve, or it will be stated clearly that this is an exact equation, solve, so that you can use the exact equation method. For example, this problem, verify that this differential equation on the board is a homogeneous differential equation of degree 2. Verify it. Which means that this problem can still be solved using homogeneous equation method. Is that okay? But you see that the problem, we're asked to solve this DE and that it is exact. And so it's of no use going to punish yourself that we're using the homogeneous equation method of solving differential equation. Since we've been told that this is what? Exact equation. Otherwise, looking at it, it is still what? Homogeneous. And one can solve it using homogeneous equation formula. Now, how do we solve this problem? The first thing you need to do to solve it using exact equation method, we're going to bring all the terms to one side. So it's going to be 6xy, and then we have the x. Then this minus the dy part will cross, it becomes plus 3x squared plus 3y squared. Then dy equal to what? 0. Now just imagine that I am the differential equation and it is said that I am exact. What do? Bring all the terms together to one side of the equation, make it equal to 0. Integrate this part of me with respect to the controlling differential coefficient. Integrate this part of me with respect to its controlling differential coefficient and put everything together. Pick the common terms. Pick the terms that are not common as well together, and then that is the solution of that exact equation. Let's do this. Let's do this. This is our n part, alright? And this is our n part. So we are going to integrate this part with respect to x, which is 3x squared plus 6xy. Now remember, with respect to x, then integrate this part, 3 x squared plus 3y squared with respect to what? Y. And of course, doing that will be equal to integral of 0 there. And then looking at this, we are integrating this term with respect to x, which means that y will be kept as what? Constant. Let's go. I will open up the bracket using the integral sign, and this is the x. So integral 3x squared dx. You'll find out that this will give us x cubed. Remember, it's going to be 3x raised to the power 3 because you're adding 1 to the power and dividing by what? The power. So 3x squared plus 1, which will give you 3x cubed divided by what? 3. You have x cubed there. And then this will give us plus. Watch this, you are integrating with respect to x. So this 6 and this y will be kept what? Constant. Let me write 6y as constant and integrate this x. If you integrate this x, you're going to get x squared over 2. So let me write this as x squared over 2. And of course, you know that these 2 should divide this 6 anyway. So let's go ahead. Then this will now give us, we are done with this part. We'll come to this part, integrate now with respect to y. So x is going to be kept what? Constant. So I'll come to this. This will give me 3x squared, you keep it constant, and then integrate it with respect to y. What is going to happen? It will welcome back the variable y. So that's going to be y, because there's no y there. So if you integrate with respect to y, it will welcome it back. Then coming over here, this is plus. Integrate this with respect to y, is going to be 3y raised to the power 3 divided by what? 3, which will give us y squared. We are done with this part and everything is equal to what? C. Picking. Now I want to pick the terms from the solution we obtained now, right? Now take note that this is going to give us, let me rewrite, x cubed plus 3yx squared. Now we have this part, and then this is 3x squared y plus y squared equal to c. We now want to pick the common term. You notice that 3yx squared and 3x squared y, they are the same thing, so they are common. Take note of it. Pick one of them. Pick one of them. So we go. I'm going to pick everything. Let me come here and then pick what I have here. This is x cubed plus 3yx squared. I'm not going to pick this again because it's common here already. Then this y squared, I'm going to pick it because I don't have it here. And everything will be equal to what? C. This is wonderful. That's the solution to that exact equation. If you solve this question using homogeneous format, you still get this as the result. Now we want to look at the next question. We are to obtain a value of k so that 2x plus k cos y dx plus 2y minus 3x and y dy equal to 0 is exact. Hence, obtain f of x, y equal to c. So we're going to get the value of k here to make this equation an exact equation. If it is not that value, then this equation would not be exact. Then proceed to solve what you get. Solve it and obtain the general solution. Now the first thing we're going to do is to write out first what was given to us from the question. And then identify our n and our n. So this was what was given to us as the differential equation. Writing it out. Then we're going to identify our n. You know, the n is usually the function that goes with the differential coefficient dx. So this is our n. Don't forget that. And then the function that goes with the n, the y, is your what? Your n. Now we are going to take the partial derivative of this. Take the partial derivative of this and equate them using the condition for exactness. So we're going to take the partial derivative of n with respect to y, take the partial derivative of n with respect to x, equate both of them and then solve for k. We are doing that because for this equation to be exact, it must satisfy this condition. This is the condition for exactness. So let us find out what we're going to get. The m over the y. Remember, if you're differentiating this partially with respect to y, it means that x will be taken as what? Constant. Let's go. Now we're going to differentiate 2x with respect to y. That will give us what? 0. Differentiate partially. Listen, if you are integrating 2x with respect to y, there is no y there. So integration will welcome back the variable y. But if you're differentiating because there is no y here, it's a pure constant and it's going to be what? 0 because of differentiation. Okay, now we go on. Come to this part, it will now become plus differentiate with respect to what? Y. So this k will be kept constant since it is multiplying a y variable. Is that okay? That's cos y. We're now going to differentiate cos y, which will give us minus what? Sine y. And of course, you see that the m over the y gave us minus k sine y. Good, take note of that. Then let us proceed and obtain del n over what? Del x. This time around, partial derivative of the function n with respect to what? X. Look at the condition on the board here. Good. Now, we are going to differentiate 2y with respect to what? X. And that is going to be 0, once again, because there is no x here, and you're differentiating with respect to x. If it were to be integration, if you integrate 2y, it will welcome back x if you're integrating with respect to what? X. Good. Now, this is going to be minus. Now, look at this. You are differentiating with respect to x. This is sine y. So you keep it constant since it is multiplying an x term. So 3 sine y will be kept constant. Then you can now differentiate the x term there. If you differentiate x alone, what will you get? You will get 1. So do you notice that this term is going to give us minus 3 sine y? Now, for exactness, we expect that del m over del y is to be equal to del n over del x. That's the condition. So the implication, minus k sine y is now going to be equal to what? Minus 3 sine y. Therefore, the value of k is equal to 3. You know, you're going to divide through by what? By minus sine y. You get your k to be 3. So for this equation, this differential equation given to us to be an exact equation, the value of k is positive 3. Okay, now we have gotten the first part of the answer. Now let us move on to obtain the general solution now. Okay, so for the general solution, for f of x comma y equal to c, it implies that the given DE, the differential equation will be, let's see, that's going to give us 2x, our k is 3, so it's going to be plus 3 cos y, okay, then dx. We are going to integrate this with respect to x, then plus integral 2y, then minus 3 sine y. We are going to integrate this part with respect to what? Y, and that will be equal to integral of 0. Then what would this give to us? Let's now integrate this part with respect to what? With respect to x. Coming over here, if you integrate 2x with respect to x, it is going to give us 2x squared over 2, which eventually becomes x squared. And then integrate this 3 cos y with respect to x is going to welcome back the variable x, and that is 3x cos y. Good. We're done with this part. We'll come to this, and then we're going to integrate 2y with respect to what? Y. That's going to give us 2y squared over 2. The 2's we cancel out, and then you'll be left with y squared. And then integrate minus 3 sine y with respect to what? Y. So that's going to be minus 3. Then if you integrate sine y, what will you get? You're going to get minus cos y. It's a standard integral. So that is going to be minus cos y. Minus cos y. Then integral of 0 give us a constant, that is c. Now we're going to pick our third noun. So that's going to be picking time. We'll pick the common terms from these two parts and pick the term that is not common, right? So let us go. This is now going to give us x squared is here, is not here. So you pick it, then plus 3x cos y. This term is common to this. They are the same, so you pick one of them. Take note that if you open up this bracket, it become plus 3 cos y, which is the same as this, right? Then look at this, plus y squared. There is y in this term, it is not here. So it's a difference, you also pick it. Now that will be equal to what? C. And we've obtained our what? Solution. This is equal to f of x comma y. And so I can still rewrite it that, okay, f of x comma y is equal to x squared plus 3x cos y plus y squared. Does that make sense? That's the solution. And if you like, it's equal to c. So we have obtained the value of k that make this an exact equation, and we've succeeded to get that function, which is the solution, f of x comma y.